In this video, this is an introduction to logarithms. So we're going to be looking at how a logarithm looks like and comparing it to its exponential form so that you can see the relationship between the two. Now first, just starting off, I'm going to create a logarithm real quick and use some values here. And let's say that we had log subscript a and b is equal to x. So here's a logarithm. Right now I'm using all variables here, right? We don't have any values. We're going to do that in just a moment. But if you have a logarithm that looks like this, we can go ahead and identify some of these components of it. So this a that I wrote as a subscript, in other words, I wrote it a little bit below the line, notice, right? So it's lower than the b. That a right there actually represents your base if it were written as an exponent. The b that you see here would represent what you would normally call the answer. So I'm just to keep it simple, I'm going to say the answer if we were to write it as an exponent. And then what you see over here, this x, it would actually represent what you call the exponent. That small value, that superscript up in the right hand side when we write it in exponential form. So now let's go ahead and let's take these same values, right, these same variables here with the word log, and let's convert all this to what it would look like if it was written as an exponent. So first of all, this a, I told you that would be your base. So I would simply write a. And I'm just going to draw an arrow, and I'm going to write the word base underneath it. That's my base value. And then we would have our exponent, right, the superscript. Right, this little x up here in the top, that's higher than the a. And I'll go ahead and draw an arrow from there, right here, and write exponent. And then we would say that a to the power of x, or a with an exponent of x, is equal to b. And I told you that would be what you normally call your answer, right, if we're trying to evaluate this. So this is just one way to look at it. When you're looking at a logarithm, well, this may look confusing because you haven't seen it before. Or if you have seen it, maybe, right, it's been a while since you've seen it. So if you see something like log a b equals x, it really just represents a to the power of x equals b. Now keep this in mind, and what we're going to do is we're just going to go ahead and use this idea to convert some logarithms that you see that I'm going to write right underneath here over to its exponential form. So let's do that right quick. For example, if we have log 256 is equal to 8, then if we wanted to write this as an exponent, well, the way we would write it is, I would take this value of 2 down here, remembering that this is my base, so I'm just going to circle it, and I would write that as my base value. And then I would go ahead and circle this last value, which happens to be my exponent, and write it up here as my exponent. So notice, right, a is the base, so 2 is the base, x, that's your exponent, so 8 is the exponent up here. And then I would set this equal to my answer, which is this 256 right here. I'm just going to go ahead and draw some arrows over. There's my 2. There's my 8. And there's my 256. So we now have taken this logarithm here and we've changed it over to exponential form. Now we're going to do that one more time just so you can see how that's done. So while we didn't calculate anything, I do want to show you at this point that these both are valid answers. That the logarithm we wrote, where we have log base 2 of 256 is equal to 8, and we have our 2 to the power of 8 is equal to 256. So let me go ahead and show you that real quick. I'm going to go ahead and hit math, and you can actually pull up your log. Notice this says log base in the menu. And it does allow us to put in the base that we want. And we do have a base of 2 for this logarithm. So I'm going to put a 2 in there. And then in the parentheses, I'm going to put the logarithm's value of 256. Click right to get out of the parenthesis, and I'm going to hit enter. And notice it does give me 8, so that validates that what I have written here is true and accurate, that a log with base 2 of 256 is equal to 8. Now, this 2 with an exponent of 8 should also be equal to 256, right? Because they share the relationship. So I'm going to go ahead and put 2 to the power of 8, because our exponent was 8. And if I hit enter, it does give me 256. Now, this is very important because we are going to be using this to find missing exponents later on. But we're going to see that in just a moment. But just know I wanted to show you mathematically that what I'm doing is accurate and it is true. So for instance, on this next one, notice we have a log of 3, and then we have 9 is equal to 2. So I'm going to go ahead and I'm going to write this one in exponential form as well. So what I'll do is I'll simply take the 3, and I'm just going to circle them as I write them, and write that as my base. I'm going to take the 2, circle it, and write that as my exponent. And I'm going to take the 9 and write that as my answer. So we have converted this from logarithmic form to exponential form. So now let's do it backwards on these next two problems. Now if I wanted to convert it from an exponent to a logarithm, I'm going to go ahead and just look at the same components. First, I know since I'm converting it to a logarithm, I'm going to write the word log. And I know in a lot of the problems you're going to see, you're just going to have a lowercase l written. I'm writing a capital L because when I write a lowercase l, to me it looks like a 1. And I don't want you to get it mixed up. So I do have an L here. This is going to be log. Next, I want to go ahead and write my exponent as my subscript. In other words, the one that's a little bit lower than the letters in the other numbers. So if I come over here, right, my subscript is always going to be my base. So I'm going to circle it. My base is going to be 12. So I'm going to write a 12 right on the line, right there. Now, the next thing I want to do is I want to write my answer. So my answer is this 144. So that's what I'm going to write next, and it's going to be above the line. And then I'm going to go ahead and write my equal sign. And finally, I'm going to write my exponent over here by itself. Now my exponent was a positive 2. So I'm going to put a positive 2 there. And so now you can see where the numbers went over. So we had our 12. I'm just going to draw an arrow. There's the 12. There's the 2. And there's my 144. And we have now taken this exponent and written it as a logarithm. So let's do the same thing one more time with this bottom one here. And by now you probably got this down. You're probably looking at it going, okay, I can understand where to put the numbers. In our next video, I'm going to take it a little bit further and show you how to do some solving of these. So let's go ahead and I notice my base is positive 5. So I'm going to put that right there. And I notice my answer is 25. And that's all set equal to my exponent, which is also 5. And that's how we would convert that exponent to its logarithmic form. Now, one last thing I want to talk about is what we call a common log. Now, there are common logs, which means that it looks like it's missing a component. For instance, if you look at this is common right here, log 9. And I'm going to grab my calculator real quick, and I'm just going to put it into the calculator so that we can evaluate it. So if I go ahead and I just hit the word log on my calculator, it automatically goes to a common log. And I can put a 9 in there and close parenthesis and hit enter, and it gives me this decimal strand, right? 0.954 and so on. Now, with this common log, when you're looking at it, you might be going, Mr. H, if you asked me to write this as an exponent, you might feel that it'd be difficult because you're missing that base value. Now, when you have a common log like this, the reason I'm using that word common log is that its base is a common value. And we always, anytime we have one that does not show the base, it does not indicate the base, that means that the base is simply 10. So log 9 is really just log with a base of 10, 9. And I'm going to show you, if I evaluate each one of these in the calculators, it is going to give me the same value. But I wanted to make sure I told you that because you may get one like this on some of the work you're doing and have to determine what the base is. in order to solve the problem. Or just knowing it, right? It tells you what number goes down there, just so you can understand that there are some instances like that. I also like to say that it's implied. A good, if you compared it to something you already know from Algebra 1, for instance, a square root, it's always implied that the index, the number above the radical on the left, is a 2. And so just keep in mind, sometimes we imply things in mathematics, and that's the situation here. Now I'm just going to type this in. We saw log 9 is 0.954. I'm going to go ahead and hit math. I'm going to go up to it says log base, where I can put my base in. I'm going to type in a base of 10. I'm going to type in a 9. I'm going to hit enter, and you're going to notice that it gives me the exact same answer. So whether I put that base of 10 in there, or I leave it off and just use log 9, you're going to get the same value. And that's because if I write it as log 9, I am using a common log. In other words, I expect everybody, if I wrote this, to understand that there is a base there. It's invisible, but it's a 10. And so I'm just going to write right here, roughly, this was 0.954. And this one too was 0.954. So if somebody gave you, just for an example, let's say it was a bonus question or something, and they said, well, we want you to tell us what log 9 is in exponential form. So I'm going to write over here, exponential form. And if you wanted to write that in exponential form, what you'd have to do is just remember that there is a 10 down there. So you would simply write this as 10. And then it would be to the power of 0.954. Now, of course, I just kind of rounded that, right? I didn't put the whole answer, but I rounded it off. 0.954 is going to be equal to 9. So you can write it. You just have to know that if it's missing the value there, if it doesn't show a base, that base is 10. And that's everything you need to know to be prepared for the next video. Now there is a purpose for this, and I'm going to show you in the next video what the purpose of this is. There's a good reason why you would want to convert exponents to a logarithm, and that's when you're trying to solve for a mixing exponent. So if you're having a missing exponent, especially if it's one that's a fractional value, the logarithm, by converting it, it makes it very easy to solve. And if you don't do it that way, it could be very challenging, very difficult, near impossible. So let's go ahead and take a look at the next video if you feel comfortable with what you've seen here.